Now let us let n be negative binomially distributed with parameters v greater than 0 and p somewhere between 0 and 1. We now wish to find q0, a, and b so that the recurrence relation is satisfied. So let's first find out where to start our recurrence. So the probability that n is equal to 0 is given as, well, let's take a look at the point probabilities down here. So here we have the point probabilities in the negative binomial distribution. It's given as v plus 0 minus 1 choose 0 multiplied by p to the v multiplied by 1 minus p to the 0. Now the general binomial coefficient v minus 1 choose 0 is defined down here, where we see that the number of elements we choose is also the number of terms in the numerator. And if there are 0 elements to choose, the numerator has 0 terms, in which case the convention is that we let the numerator be 1, in the sense that we regard it as something to the 0th power. So this is just 1 multiplied by p to the v multiplied by 1 minus p to the 0, which is 1 again. So it's just p to the v. Now let k be some natural number, and we will try to figure out how this recurrence relation works. Now qk is equal to this point probability down here, the probability that n is equal to k. So it's v plus k minus 1 choose k multiplied by p to the v multiplied by 1 minus p to the k. And then we have qk minus 1 divided by qk minus 1, just because we want to get qk minus 1 in there in some way. What do we then have? Well, let's divide by qk minus 1. So it's v plus k minus 1 choose k divided by v plus k minus 1 minus 1 choose k minus 1 multiplied by p to the v divided by p to the v multiplied by 1 minus p to the k divided by 1 minus p to the k minus 1 multiplied by qk minus 1. So what I've done is just to plug in the value of qk minus 1 in the denominator. The p to the v and p to the v, they cancel each other out. And then I just have 1 minus p multiplied by this thing here, which seems pretty extensive. So let's just call this star, and then multiplied by qk minus 1. Now let's try to take a look at how star looks. So we'll just give star its own bubble. Now star is equal to v plus k minus 1 multiplied by v plus k minus 2 and so on, all the way down to v, divided by k factorial. And then we have the inverted version of this binomial coefficient down here. So I have k minus 1 factorial, and then v plus k minus 2. And since there are only k minus 1 terms in here, so the k minus 2 comes from the k minus 1 minus 1, right? And then I go k minus 1 terms down, so I also end in v down here. Now all of these terms cancel with all of these terms here, and most of the terms in all of the terms in this factorial cancel with most of the terms in k factorial, and what we end up with is v plus k minus 1 divided by k, which in turn is 1 plus v minus 1 divided by k. So qk is equal to 1 minus p multiplied by 1 plus 1 minus p multiplied by v minus 1 divided by k, all of this multiplied by qk minus 1. Okay. What is the a and what is the b? Well, it seems quite surely that the 1 minus p is our a, and 1 minus p multiplied by v minus 1 is our b. So we can write a is equal to 1 minus p, and b is equal to 1 minus p multiplied by v minus 1, which is just equal to a multiplied by v minus 1. Now, which regions should a and b lie inside? Well, we can think a little bit about that. Since 1 minus p should be between, well, p should be between 0 and 1, right? So p lies between 0 and 1. That forces a to lie between 0 and 1 as well. And apart from that, we can see that b is equal to a multiplied by v minus 1, and v is greater than 0, so that implies that v minus 1 is greater than minus 1. And that implies that a multiplied by v minus 1 has to be greater than minus a. So that means that b has to be greater than minus a. And what does that mean? That means that a plus b has to be greater than 0. So we require that a lies between 0 and 1, and that a plus b is greater than 0. And so we'll write down the last AB region. The AB region for the negative binomial distribution requires the a and b to satisfy a between 0 and 1, and a plus b greater than 0. And in terms of how to draw it, well, we can see that if I let 1 be here and a has to lie between 0 and 1, then we're definitely restricted to this strip here, and a plus b has to be greater than 0. And as mentioned earlier, this means also that b has to be greater than minus a, and b equal to minus a is this diagonal line here, which means that the entire AB region of the negative binomial distribution is actually all of this, all the way up. And this is by far, in terms of size, the biggest AB region that we have. Now we have established the AB regions for all three distributions, and we have shown that all three distributions satisfy the AB condition.